Hi friends, welcome to our channel. In this video, we are going to look at today's daily challenge problem, power grid maintenance. So in this video, we are going to use unifund technique. And the data structure we are going to use also involved a sorted container, right? So here a sorted container, so we are going to use sorted set for two reasons. First is for membership check, and the other is for the smallest element due to the problem assumption, right? So here I'm not going to read through the whole problem, but I want to emphasize several points. First, each grid is nothing but a connected component if we regard the thing here as a graph. So this is the one thing. Another thing is that when we get this for 1x, right? So we want to check the smallest ID. So we can use sorted set. So this way we represent the grid with a sorted set of of cables, right? So that's basically the main point. So here you can look at the two examples here and do the return. So the constraints, let's see, C is bounded above by 10 to the power 5. In other words, this problem set is not small. We need to think of term complexity. So here the number of lengths is less than this number. So this is the total number of less than or equal to this number. So this is the total full graph, or fully connected graph, right? So each two cables or two nodes have a connection. So this is the number of edges, right? So all the others are roughly consistency assumptions. So with that said, so we are ready to do the coding directly. I guess the logic is rather straightforward. Before we do that, let me make some general comments. First, concerning on the methods. So if we want to compute connecting component, typically there are two classes of methods. One is unifund, the other is traversal. You can use DFS or BFS, but in this video, I'm going to use unifund, right? So with that said, let's prepare. First, I'm going to implement the unifund part. So I'm going to have a roots. So this tracks the roots of each cable. So here I'm going to use a list. So the range from zero to C plus 1. So but what we are going to use is the 1, 2 up to C, right? And this is one. Another one is the racks, right? So the rack I'm going to use 1 times C plus 1. So again, we are going to use the indices from 1 to C, right? But 0 is pseudo. So with that said, let's define two methods. So one is find, right? Given a root, given a cable or given an index, let's find its root. So here I'm going to use this result and track the roots of this result, right? That's the I. First, we want to write a while loop. While result does not equal to roots result. Then basically what we want to do is we set the result to be the roots of the result. Then after this while loop, so the result and the roots of the result will be the same. So we're going to return the result. But here I want to add one thing. So here, so I'm going to apply these roots in both sides. So in other words, we set the roots of the result variable to be the roots of that root. So this is playing the role of path compression, right? So if you check the corresponding playlist in my YouTube channel, actually you can see in a lot of problems, so we used path compression. So this is rather standard. Another one is a union, right? So given two cables or indices. So let's first find its root I, root j, to be, because we have implemented the find method, we can use the find method. And then first, if root I equals root j, means they are in the same cluster, right? So then we don't do anything. Rather, if they're not, so what we do is that, so we can directly set a root. For example, set the roots of root G to be root I, but that's too vanilla. So here I'm going to use union by regs. That's the role of this variable, right? So the regs of root I, if it's greater than or equal to regs of root G, then we are going to set the roots of root I, root G to be root I. And then we increment the rec of root I by that of root G, corresponding to combine the two cluster. Otherwise, so we do the same thing but in the other direction. So what we do is we set the root of I to be that of G, and then the regs of G is incremented by that of root I, right? So that's it. So here, that's the find and the union. So here, this part, we are taking rec into consideration is a so-called union by rec, right? So both path compression and the union by rec can actually accelerate the process of finding or union. So that's one remark. Next, we are going to think of the problem logic, right? First, I'm going to union all this with this connections, right? So basically, for UV in connections, so I'm going to union them. Then I want to get all the clusters, so all the power grid in the notion of this problem. So let's define get clusters. So so let's use D. So the collections. So I'm going to use default dict. So here I'm going to use sorted set, right? So as I mentioned, so the set is easy to check membership, especially in this case, right? So if station offline, then the check is resolved by the operational station with smallest ID. So this is the sorted part saving this one, and the set part is saving this one. If the station X is online, it's resolved itself automatically, right? So what we do is for I in range, so 1, ending at C, right? So let's first find the roots of this R, find the representation of that power grid, and then I'm going to do this dr. So this will be a set, right? So I add the I, meaning that the cable is associated with this cluster represented by R, right? So then we just need to return and D. So this is the hyperfunction. So next, let's actually prepare the return, right? First, let's get this part of information. So get clusters. Actually, you can print it out for a check, right? So let's do this. Let's do. That's the run. Right. So this gives you this one. So this actually is just a one. They are all connected, right? You can also see the smallest one, right? So this helps you understand this part. So next, I'm going to return the thing. So let's initialize a result variable. So then I'm going to iterate canned idx in queries, right? So first, I want to get the the representation of this cable in the grid, which power grid is in, is represented by R, right? So then if canned equals 2, then we're going to discard this one because it's going to be off. So what we do is info R, so discard idx. Notice that this discard function is actually here is better than the remove function, because in the sorted set, if the IDX is not in this container, then if you use remove, it will raise error. But if you use discard, if IDX is not an element in the sorted set yet, it just do nothing, right? If it's were in it, it's going to ignore that or discard that. So this is the one. Otherwise, the count will be 1. So then we're going to in this bullet point, right? So here, then first, if not, info R. So in other words, it's corresponding. No operation station exists in that grid. So we're going to append this with -1. Otherwise, there are operational stations there. Then we want to check first if this IDX itself is on, right? If IDX in info R, right? So this is for membership check, because this is a set, right? This is the O1 operation. So then what we do is just append IDX. And otherwise, we want to append the smallest element in that PORX grid. So what we do is append info R 0, right? And then here, finally, we are going to return this result. So before we do anything, let's first run it, check. Yeah, it passes the 2 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So here, when I do the annotation, here I write use sorted set or heap. I will see here sorted set is better than heap, because for heap we can easily get the smallest element, but it will need a linear time complexity operation in order to check membership, because that's also a list, right? So that's one comment. Another comment is that you can do this problem, for example, for finding this part of information using traversal, either DFS or BFS, but that's a good exercise. We'll stop here for this problem. I would say if you are interested in practice more on Unifund, you can find the Unifund playlist in my YouTube channel and do the exercise there. There are more than 20 problems from LeetCode. With that said, thank you for watching.